544 div 3e k balanced teams. So we've been given n students with each student having his own rating. We need to form k teams out of from these n students such that in every team the rating difference between the guy with the maximum rating and the guy with the minimum rating is less than or equal to 5. Uh, and we need to form less at most k such teams. And the thing we need to maximize is the total number of students in all the k teams, right? This so the way we do this is, first of all, we sort the given array, because this is sorting is natural in this case, because we need to check for within a team the difference between maximum and minimum rating should be less than or equal to 5. So hence sorting is natural. Now the first attempt at this solution uh, from my side was DP, where I defined DP of I comma KL as a maximum number of students that can be taken in KL teams from student index I to n minus 1, and answer would be dp of 0 comma k, and the transition would be given as dp of I comma kl is the maximum groups 5 size from I to j plus dp of j plus 1 kl minus 1 maximum over all j. What this is saying is basically, for every j greater than I, will check what is the maximum group of size 5, maximum valid team, from that can be from elements I to j. What is the maximum such team size possible? This is one team, and then we'll need to choose at most KL minus 1 teams from j plus 1 to n minus 1 indices. So that is given by this dp. But the problem with this is we have n transitions, n squared states, so order of n cube solution. We need to do better than this. So the way we optimize this time complexity is via an observation which says that for every I, it is always optimal to take the last j such that if at all, uh, if at all I uh, in, is the beginning. I mean, is the lowest rating of a team. It is always optimal to take all the elements uh, in in the team such that all the elements from I to j in the team such that j is the last element where aj minus ai is less than or equal to 5. With this observation, we I try to make this dp where dp of I comma kl is j minus I plus 1, where j is found via an upper bound, and this is the size of the largest team that can be formed with I as the first element of that team. Okay, plus dp of j plus 1 comma kl minus 1. This is, we need to choose kl minus 1 more teams from j plus 1 to n minus 1. But this is wrong because we're not even considering the case when I might not be in the team, in any team. So the way we do that is, we so for to incorporate this, I tried to, first of all, I tried to uh, run a loop where what I was doing is that dp of I comma kl is equal to dp of I dash sorry is equal to maximum of j minus I dash plus 1, where j is j dash minus I dash plus 1 plus dp of j dash plus 1 kl minus 1. I was doing this where j dash is the index corresponding to I dash, and I dash varies from I to n minus 1. So this is, although this is a valid solution, this gives the order of n cube solution also again, which we don't want. So a simple way to get around this is to simply uh, take the case when we are not considering I to be in the team. So if we dp of I comma kl is the number of maximum number of students we can get from I to n minus 1 with kl teams, with at most kl teams. So this is a case when we are not considering the ith index to be a part of any team. So it will simply be I plus 1 kl, and this is when we are considering I to mark the beginning of a team. So this is the size of the maximum size of the current team, and this is the number of ways to uh, maximum number of students we can pick from j plus 1 to n minus 1 index. So yeah, this is the correct code, and the code is simple. This is the code, very short code. Yep.